Welcome to Flip Lesson 45 for the 5th grade. Today we're looking at classifying quadrilaterals. As we look at quadrilaterals, we need to understand that a quadrilateral is a four-sided polygon. And from there we can get into lots of different groups. If I were to ask you to name some four-sided quadrilaterals, well, you probably could come up with a decent list. But what we want to do is we want to break quadrilaterals into the three main groups. Can you tell me what the three main groups of quadrilaterals are? Hopefully you guessed right, and you came up with trapezoid, parallelogram, and trapezium. Now we can start to get a definition of why these are three main groups of quadrilaterals. All right? By looking at our definitions of what these shapes are, we can really understand why these three form their own groups. Right? Starting on the right, we can see that trapeziums have no parallel sides. Look at the four sides of this shape, and there are no parallel sides, which makes it fit into the trapezium family. If I go all the way to the left, you can see that we have a trapezoid. We have one set of parallel sides. Right? This side here and this side here are parallel. This idea, those lines right next to each other like that. So we have one set, since this line and this line are not parallel. And finally, we have our last type, which is a parallelogram, which has two sets of parallel sides. So this line is parallel to this line, and this line is parallel to this line. By looking at those definitions, we have our three types of quadrilaterals. From here, we can actually take parallelograms and we can break it off into more specific types of parallelograms. And so we can understand our first two main groups. Now these are two shapes are going to have parallel sides, two sets of parallel sides. But there's also going to be another unique feature about them. Right? Our first two unique types of parallelograms are the rectangles, and the other one would be the rhombus. Right? A rectangle has that two sets of parallel sides, but it also has four right angles. And those are the only rules that apply to a rectangle. Beyond that, it doesn't matter what our lengths and our widths of those parallel sides are. Right? So the lengths don't matter in a rectangle. Right? As long as this one and this one are parallel, and this one are parallel, which in a rectangle means that this side and this side are going to have the same length, just like this side and this side are going to have the same length, because of the shape that it's in. Right? But the key thing here is that it has four right angles, which can very easily be seen, especially if we get rid of all these drawings back. Right? We see the right angles right there. Our other type of parallelogram, right, is our rhombus. Right? Once again, two sets of parallel sides. See those two sets. But our specialty for this type of shape is all four sides have the same length. Because each of those lengths is the same size, we have a rhombus. So we have this explanation, right? Angles are not the same, but this time all sides. And of course, if we combine all of these ideas together, we get our last and final type of quadrilateral, which is a square. Right? Two sets of parallel sides, four right angles, and all four sides are the same. So we have these unique rules that fit into this idea. Right? So hopefully you copied this down and you understand all these different rules. That's going to help us in the next part. Next part says we want to name these quadrilaterals. And it says use all names that apply. Because sometimes we can name a shape by more than one of these quadrilateral names, especially if it's in that parallelogram family. Let's start with our first shape. First thing we need to do is identify the bigger family. So we need to look at parallel lines. Right? Are there any parallel lines in our first shape? Right? Shape number one. And looking, I found this line is definitely parallel to this line, but the other two lines are not parallel. And so we have one set of parallel lines, which would Look quickly back, you see one set of parallel sides, that would make it a trapezoid. And trapezoids are by themselves, and that's all we can do with that. If you look at shape number 2, right, we want to start by identifying parallel lines. Looking closely at this, there are no parallel lines. Looking back at our diagram, you see no parallel sides, which means that this is a type of trapezium. Next shape, shape number 3. You probably very quickly said, well, that's a rectangle. And that is very true. That is a rectangle. But now the question is it anything else? If we look back at our diagram real quick, we can see that rectangles fit under the family of parallelograms. And so that means that it is also a parallelogram. However, it is not under rhombus, it is not under square, so it is not a rhombus. It is not a square. So we would also have to call this a parallelogram. Now we can get to shape number 4. As we look at shape number 4, we got a little bit different shape, a little bit different angles, so now we got to really think this through. Start by looking at the idea of parallel sides, right? And it's very easy to see that there are some parallel sides, parallel, 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 parallel. So it must be a parallelogram. Okay? So we have that. Okay? I'm just going to abbreviate just a little faster. So it's a parallelogram. Right? What else can we say this shape is? Next, we're going to look at angles, right? And we got a right angle, right angle, right angle, right angle, right? So it's a parallelogram, 2 sets of parallel sides, and it's a right angle, so that means it's a rectangle. If it fits that roof, fits that roof. We can also look at the lengths of the sides. Right? The lengths of the sides say that it is, they're all equal. That would make it, right, a rhombus. And now that we look at all this stuff, we have the 90-degree angles, we have the equal length sides, we have parallel sides, but this must also be a square. And if we take a moment, we can very easily see that it actually is a square, even though it's turned that angle, right? So we have that. All right, I'm going to leave it to you to try and work with this idea of quadrilaterals and name these different types of quadrilaterals. All right, make sure you use the diagram to help you understand how to name quadrilaterals. That is lesson 45.